Hello. In this video, I'm going to show you how to simplify square roots that have a negative radicand using division of primes method, sometimes referred to as the birthday cake method because it looks like a cake. The first thing that you want to do on example 1 is you want to break this up into the square root of 48 times the square root of -1. And this is important because we know that the square root of -1 is the imaginary number I. By separating this, it allows us to simplify the square root of 48, and then we can attach the I to that answer. To do the division of the primes method, you need to know your prime numbers. So here are just some of the first prime numbers that come out numerically. You might want to know a little bit more than these ones to do this method. So the first thing you do to use this method is you put your radicand, 48, at the base of your cake. You always want to look for the smallest prime number that goes into 48. The smallest prime number that goes into 48 is 2. 2 goes into 48 24 times. We're going to do that again. The smallest prime number that goes into 24 is 2. 2 goes into 24 12 times. The smallest prime number that goes into 12 is 2. 2 goes into 12 6 times. The smallest prime number that goes into 6 is 2. 2 goes into 6 3 times. The smallest prime number that goes into 3 is 3. 3 goes into itself once. When you get to 1, you're done. 1 is that candle to your cake. Because we are dealing with square roots, we want to look for pairs of numbers to leave the square root symbol. Here I have a pair of 2's that can leave that square root symbol. And I have another pair of 2's that can leave the square root symbol. 3 does not have a pair, so 3 needs to stay inside of the square root. We also have to deal with that square root of -1. We know that the square root of -1 is I. Now you'll notice that I put the I before the radical. And that is because when we write our answer, if I were to have the answer the square root of 3i, it's really hard to tell if that I belongs underneath the radical or not. So to avoid this confusion, we always write the I in front of the radical symbol. So whenever you have an imaginary number that includes a radical of any kind, you always want to put I before that radical. So now I can just multiply these together. 2 times 2 times I is 4i. So my answer is 4i square root of 3. This is one term. Remember, terms are separated by addition and subtraction symbols. I don't have any of those here, so this is just one term, and this term is an imaginary number because it includes I. Let's try this process again on example 2. So on example 2, I have 6 square roots of -175. The first thing that I notice is that I have a coefficient of 6. So I'm going to go ahead and write that down out in front. The next thing that I'm going to do is I'm going to separate the square root of -175 into the square root of 175 times the square root of 1. From here, we want to simplify the square root of 175. To do that, I'm going to use the birthday cake method. The smallest prime number that goes into 175 is 5. 5 goes into 175 35 times. The smallest prime number that goes into 35 is 5. 5 goes into 35 7 times. The smallest prime number that goes into 7 is 7. 7 goes into itself 1 time. When you get to 1, you're done. This is the candle to your cake. So if I come back over here to my problem, we have that coefficient of 6 that's out in front. And then we just simplified the square root of 175. We're looking for pairs of numbers to leave the square root symbol. And here I have a pair of 5s that can leave. 7 doesn't have a pair, so 7 is going to stay inside the square root symbol. The square root of -1 is I. So now we can go ahead and we can multiply all this together. Remember, we want all of our coefficients to go in front of our radical symbol. So 6 times 5 times I is 30i. And then we're going to bring down our square root of 7. So our answer is 30i square root of 7. Again, this is one term. And this one term is an imaginary number because it includes the variable I. Technically, I isn't a variable because it represents the number, the square root of -1, but we treat it like a variable whenever we're doing any operations with it. Let's go ahead and try one more example, and we're going to follow the same exact process that we just did in the previous two. I have this 4 out in front as a coefficient, so I'm going to go ahead and write that down. That way I do not forget about it. I'm going to separate the square root of -28 x to the 4th into 3 parts. The square root of -28 can be rewritten as the square root of 28 times the square root of -1, because 28 times -1 is -28. And then I'm going to deal with that variable separately, so I'll include the square root of x to the 4th. So we're going to look at this one part at a time. Let's start off by bringing down our 4. We want to simplify the square root of 28. And if you're watching this video, you want to do that by using the birthday cake method or division of primes. So the smallest prime number that goes into 28 is 2. 2 goes into 28 14 times. The smallest prime number that goes into 14 is 2. 2 goes into 14 7 times. The smallest prime number that goes into 7 is 7. 7 goes into itself 1 time. When you get to 1, you're done. This is the candle to your cake. We are looking for pairs of numbers to leave the square root symbol. Here I have a pair of 2s that can leave. 7 does not have a pair, so 7 is going to stay inside of that square root symbol. We know that the square root of -1 is I. And then I have the square root of x to the 4th. Well, remember that x to the 4th means that we have 4 x's being multiplied together. Just like how when we did the birthday cake method, we were looking for pairs of numbers to leave the square root symbol. Here we are going to be looking for pairs of x's to leave the square root symbol. So here I have 1, 2 pairs of x's to leave the square root symbol. X times x is x squared. So let's multiply all of our coefficients together. 4 times 2 times I times x squared is 8i x squared. And then we're going to bring down the square root of 7. 8i x squared square root of 7 is our answer. Again, this is one term because terms are separated by addition and subtraction symbols, and I don't have any of those. And this one term is imaginary because I is a part of our answer.